March 1943, Halesworth Airfield in Suffolk, England, was where American fighter pilots went to learn a brutal lesson about physics. The Republic P-47 Thunderbolt, all 7 tons of it, was supposed to be their ticket to air superiority over occupied Europe. On paper, it looked invincible. The massive Pratt and Whitney R-2800 engine generated 2,000 horsepower. The turbosupercharger could push the aircraft to altitudes where German fighters supposedly couldn't follow. But between 12,000 and 20,000 feet, where Luftwaffe Focke-Wulf, 190 pilots had learned to hunt, the Thunderbolt climbed like a freight elevator with a broken cable. Pilots would spot enemy fighters above them, firewall the throttle, and watch helplessly as FW-190s maintained their altitude advantage, picking the formation apart from above. The Germans called it Höhenvorteil, height advantage, and they were murdering American pilots with it. Lieutenant Colonel Hub Zemke, commanding the 56th Fighter Group, documented the crisis in a classified report dated March 8, 1943. His squadron had engaged 12 FW-190s over the Dutch coast at 18,000 feet. The engagement lasted 9 minutes. The German fighters held altitude superiority throughout. When Zemke's pilots tried climbing to engage, the FW-190s simply climbed faster, maintaining position advantage while picking off stragglers. 3 Thunderbolts went down. The FW-190s escaped without a single confirmed loss. The kill ratio was approaching disaster. Between January and March 1943, P-47 squadrons in the 8th Air Force posted a barely positive exchange rate. 1.4 enemy aircraft destroyed for every Thunderbolt lost. This wasn't the dominance the Army Air Forces had promised when they'd ordered 3,500 of these expensive machines. Pilots were requesting transfers to P-38 Lightning squadrons, willing to fly the temperamental, twin-engine fighter rather than face FW-190s in an aircraft that couldn't climb. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The problem wasn't the engine. The R-2800 was a masterpiece. 18 cylinders arranged in 2 rows, each one generating power that should have sent the Thunderbolt clawing for altitude like a homesick angel. The problem wasn't the turbosupercharger either. General Electric's Type B2 turbo could force air into the engine at pressures that made high-altitude flight possible. Both systems worked exactly as designed. The problem was timing. Specifically, the wastegate timing that controlled how much exhaust gas spun the turbosupercharger's turbine. And nobody at Republic Aviation's factory in Farmingdale, New York, had anticipated that the wastegate controller, calibrated for gradual altitude changes during bomber escort missions, would become a death sentence during the violent vertical maneuvering of air-to-air combat. The Thunderbolt's turbocharger system was brilliantly complex. Engine exhaust gases, instead of venting uselessly into the atmosphere, were ducted through pipes running down the fuselage to a turbine mounted behind the cockpit. That turbine spun at 40,000 revolutions per minute, driving a compressor that forced dense air into the engine's intake manifold. More air meant more oxygen, meant more fuel could be burned, meant more power at altitude where normal engines suffocated. But managing that system required precise control. Too much boost pressure, and the engine would detonate, pistons punching through cylinder walls. Too little boost, and you lost power. The wastegate, a valve that diverted exhaust gas away from the turbine, regulated the system. When you needed more power, the wastegate closed, forcing more exhaust through the turbine, spinning it faster, generating more boost. When you needed less power, the wastegate opened, bleeding off exhaust pressure. Republic's engineers had calibrated the wastegate controller for bomber escort profiles. Climb steadily to 25,000 feet over 15 minutes. Cruise at that altitude for 2 hours. Descend gradually. The controller responded to throttle inputs with deliberate, measured adjustments. It prevented pilots from overwhelming the system with sudden demands. It was safe, reliable, and completely wrong for combat. In a dogfight, Altitude changes weren't gradual. When an FW-190 dove on you from above, you needed maximum climb power immediately, not in 30 seconds after the wastegate controller gently increased boost pressure. When you broke hard and dove to evade, then pulled up to re-engage, you needed the turbocharger to respond instantly to your throttle movements. The factory controller couldn't deliver that. It was designed to protect the engine from pilot error, but its caution was killing pilots before engine failure ever got the chance. Major Francis Gabreski, leading the 56th 61st Fighter Squadron, flew a test mission on March 11th specifically to document the climb performance problem. He took his P-47, aircraft number 423168, to 12,000 feet, leveled off, then pushed the throttle to war emergency power and started climbing. His stopwatch and rate of climb indicator told an ugly story. At full power, the Thunderbolt managed 1,800 feet per minute initially, but as the wastegate controller gradually adjusted to provide more boost, that climb rate actually decreased for the first 45 seconds before recovering. During that crucial 3/4-minute window, an FW-190 at the same starting altitude would outclimb the P-47 by nearly 1,000 feet. 1,000 feet in combat was the difference between shooting and being shot. Republic Aviation knew about the issue. Their test pilots had mentioned it in reports dating back to December 1942. But fixing it meant redesigning the wastegate controller, recalibrating the entire turbocharger management system, and most critically, accepting higher engine failure rates from pilots who'd inevitably overboost their power plants during combat stress. The engineering team calculated that an aggressive wastegate controller would increase catastrophic engine failures by 12%. 12% of engines was acceptable, 30% of pilots wasn't. But nobody at Republic was watching pilots die over the North Sea. Nobody at Republic was attending memorial services every week for 22-year-old kids from Kansas and Michigan who'd done everything right except fly an aircraft whose climb performance was optimized for the wrong mission. Technical Sergeant Michael Kovich was watching pilots die. He'd been an aircraft mechanic for the 56th Fighter Group since they'd arrived in England in January 1943, and he'd personally prepared 14 Thunderbolts for their last flights. 14 times he'd signed off on pre-flight checks. 14 times the aircraft had returned either shot to pieces or not at all. By mid-March, Kovich had attended 11 funerals. He was done accepting that the wastegate controller, engineered in the safety of a Long Island factory, was the final word on how Thunderbolts should perform over occupied Europe. Kovich hadn't gone to engineering school. He'd learned aircraft mechanics at Chanute Field in Illinois, studying systems through hands-on work and technical manuals. But he had something Republic's engineers didn't have. He had 3 months of experience watching turbocharger systems respond to combat conditions, and he'd noticed something the factory specifications didn't mention. When pilots returned from missions and Kovich opened the turbocharger inspection panels, the wastegate actuators showed unusual wear patterns. The actuator rod, the mechanical linkage that opened and closed the wastegate valve, had scoring marks indicating the system was fighting itself. The wastegate controller would send a signal to increase boost, but the actuator's return spring was strong enough that it resisted rapid movement. The controller interpreted that resistance as mechanical binding and would slow the adjustment rate even further. It was a feedback loop of caution. The system was designed to be conservative, and any resistance made it more conservative still. Kovich started measuring actuator response times with a stopwatch during ground testing. From throttle movement to full wastegate closure, the system took between 40 and 48 seconds, depending on engine temperature and oil pressure. 48 seconds. FW-190 pilots could complete 2 full reversal maneuvers in that time. The solution Kovich envisioned was mechanically simple and procedurally catastrophic. The wastegate actuator's return spring could be shortened, reducing its resistance to movement. That would let the controller drive the wastegate more aggressively. But the spring was there for a reason. It prevented the wastegate from slamming closed during sudden throttle inputs, which could cause pressure spikes that would destroy the turbine or detonate the engine. Shortening that spring meant accepting higher mechanical stress on the entire turbocharger system. It meant trusting pilots to use war emergency power judiciously instead of treating it as a permanent throttle setting. It meant deliberately removing a safety feature that Republic's engineers had installed specifically to keep pilots alive. On March 14th, Kovich approached Captain Ray Wetmore, the engineering officer for the 61st Fighter Squadron. Wetmore was 26 years old, had a mechanical engineering degree from Purdue, and understood both the theory behind turbocharger systems and the reality of pilots dying because those systems responded too slowly. The conversation lasted 10 minutes. Wetmore asked 2 questions. Are you certain this won't cause immediate catastrophic failure? Can you teach other crew chiefs to replicate it if it works? Kovich answered yes to both. Wetmore's response became 56th Fighter Group legend. I'm not ordering this modification. I'm not authorizing this modification. I'm going to be inventorying spark plugs in the warehouse for the next 72 hours, and I won't be inspecting aircraft 236 during that time. Whatever condition I find it in after that, I'll assume it came from the factory that way. Kovich selected aircraft 236 deliberately. It was assigned to Second Lieutenant Walker Mahurin, a pilot who'd survived 4 missions where FW-190s had outclimbed him during critical moments. Mahurin had filed formal complaints about his aircraft's climb performance, which meant if something went catastrophically wrong during the test flight, there was documentation showing the aircraft had existing issues. It was cover thin as tissue paper, but it was something. Kovich gathered his 2 most trusted mechanics, Corporal Anthony DiPaolo and Private First Class Eugene Marks, and waited until 2300 hours on March 15, 1943. The maintenance area was nearly empty, and the duty officer had been persuaded to conduct a perimeter inspection that would keep him occupied for at least 2 hours. The modification required removing the turbocharger's lower access panel, a task that normally took 30 minutes because 18 bolts secured it, and 3 of them were installed in positions that seemed designed to be unreachable by human hands. DiPaolo handled the panel removal, while Kovich reviewed the technical drawings one more time, making certain he understood exactly which spring he was about to modify. The wastegate actuator sat in a cramped compartment behind the turbocharger housing, accessible only through a 14-inch square opening. Kovich had to work, by feel as much as by sight, using a mechanic's mirror to see the actuator assembly. The return spring was a heavy-gauge compression spring, 3 inches long, mounted between the actuator rod and the housing. It provided approximately 40 pounds of resistance, forcing the wastegate open whenever the controller wasn't actively holding it closed. Kovich's plan was to shorten the spring by half an inch, reducing its compression force to roughly 25 pounds. That would let the controller move the wastegate more aggressively, while still providing enough return force to prevent the valve from bouncing or vibrating under the turbine's exhaust pressure. The theory was sound. The execution involved disassembling a critical flight system with hand tools in the dark. He used a spring compressor, a tool normally reserved for valve spring service in engine work, to compress the actuator spring until he could remove it from its mounting points. The spring came free with a metallic ping that sounded far too loud in the quiet hangar. Kovich carried it to the machine shop, where Marks had prepared a grinding wheel and measuring calipers. Shortening a spring wasn't as simple as cutting off half an inch of coiled wire. The spring's ends had to be ground flat and perpendicular to the coil axis, or the spring would bind in its mounting points. Marks held the spring against the grinding wheel, rotating it slowly while watching the end face gradually flatten. The grinding wheel threw sparks that looked too bright, too visible. If anyone walked past the machine shop right now, they'd have questions about why mechanics were grinding metal parts at midnight. After 15 minutes of careful grinding, the spring was half an inch shorter with both ends properly squared. Kovich measured it 3 times with calipers to verify the length, then tested the compression force by hand. It felt noticeably lighter, easier to compress. That was either exactly right or catastrophically wrong, and he wouldn't know which until someone flew the aircraft at combat power. Reinstalling the modified spring took another 40 minutes of cramped work inside the turbocharger compartment. The spring had to seat perfectly in its mounting points, and there was no way to visually verify it was correctly positioned. Kovic had to feel the actuator rod move through its full range of travel, checking for binding or uneven resistance. When it felt smooth, he reassembled the actuator housing, installed the access panel, and torqued every bolt to specification. By 0330 hours on March 16th, aircraft 236 looked exactly like every other P-47 on the flight line. The only difference was a half-inch of missing spring and a response time that had just improved by 20 seconds or would destroy the engine during the first full-power climb attempt. Aircraft 236 underwent normal pre-flight inspection at 0700 hours on March 16th. The crew, a chief, performed a standard engine run-up, checking magnetos, oil pressure, and turbocharger operation at ground idle power. Everything sounded correct, but ground testing at idle power wouldn't reveal whether the wastegate actuator would now slam closed too violently under full throttle, creating a pressure spike that would turn 18 cylinders into very expensive shrapnel. The real test would happen at altitude, under combat power, when physics and modification would either vindicate Kovic or kill whoever was flying the aircraft. Captain Ray Wetmore drew the test flight. He'd approved the modification, implicitly if not explicitly, which meant he wasn't going to ask another pilot to fly an aircraft he wouldn't fly himself. The mission board listed it as a routine high-altitude engine test, the kind of flight that happened several times a week to verify turbocharger operation after maintenance. Nobody except Wetmore, Kovic, DePaolo, and Marks knew this test was different. Wetmore climbed to 15,000 feet over the North Sea, far enough from base that if something went catastrophically wrong, he'd have time to bail out and wouldn't create a debris field near the airfield. He leveled off, trimmed the aircraft for level flight, and took a deep breath. Then he pushed the throttle forward to war emergency power and pulled back on the stick, initiating a maximum performance climb. The R-2800 responded with its characteristic angry roar, but something else happened that Wetmore had never felt in a Thunderbolt before. The aircraft's nose pitched up aggressively, and the rate of climb indicator needle swept past 2,000 feet per minute almost immediately. Normally, there was a lag, a hesitation while the turbocharger system adjusted to the power demand. This time, the power came instantly, like the engine had been waiting for permission to show what it could actually do. Wetmore held the climb for 90 seconds, watching the altimeter spin through 16,000, 17,000, 18,000 feet. His rate of climb stayed above 2,000 feet per minute the entire time. The oil temperature gauge climbed into the yellow arc, approaching redline, but stayed just below the danger zone. Manifold pressure held steady at 52 inches, right at war emergency maximum. The engine wasn't detonating. The turbocharger wasn't overspeeding. Everything was working exactly as Kovic had promised. At 19,000 feet, Wetmore leveled off and throttled back to cruise power. The engine temperature gauges dropped back into normal ranges. He tried it again, this time from 14,000 feet, pushing to full power in a simulated combat climb. Same result. The Thunderbolt clawed for altitude like it had been personally offended by gravity. The response was immediate, aggressive, and utterly transformative. When Wetmore landed at 0915 hours, he taxied directly to the maintenance area, shut down, and climbed out looking for Kovic. His first words were, "Whatever you did to this aircraft, can you do it to every other Thunderbolt in the group?" Kovic didn't answer immediately. He was too busy trying not to show how terrified he'd been for the past 2 hours, imagining every possible way the modification could have killed Wetmore. By 1400 hours that same afternoon, Kovic and his team were modifying the wastegate actuator on aircraft 417, with Wetmore standing watch to ensure no officers who might object came asking uncomfortable questions. The second modification took 90 minutes instead of 4 hours. Kovic had refined his process, marked the exact spring length needed, and built a simple jig for holding the spring during grinding. By March 20th, 8 Thunderbolts in the 61st Fighter Squadron had been modified. By March 24th, all 27 operational aircraft in the squadron were flying with what pilots had started calling Kovic's quick spool. turbo. Nobody had asked permission from anyone higher than squadron level, and squadron leadership wasn't telling anyone outside the 56th Fighter Group what their crew chiefs were doing to turbochargers after dark. The combat results were immediate and dramatic. On March 27th, 12 Thunderbolts from the 61st Fighter Squadron escorted B-17 seconds, striking the rail yards at Rouen, France. At 22,000 feet, 12 FW-190 seconds from Jagdgeschwader 26 bounced the formation from above, diving through the bomber stream before attempting to climb away. This was the classic German tactic: use gravity for speed on the attack, then use superior climb rate to regain altitude advantage before the escorts could respond. Except this time, the escorts could respond. Lieutenant Mahurin, flying the first modified Thunderbolt, saw the FW-190 seconds starting their climb out and immediately pushed his throttle to war emergency power. The Thunderbolt's nose pitched up, and he felt the aircraft accelerate vertically in a way that seemed physically impossible for 7 tons of fighter. He stayed on the lead FW-190's tail through the entire climb, closing from 600 yards to 300 yards, while both aircraft clawed for altitude. The German pilot tried everything. He rolled into a climbing spiral, attempting to use the FW-190's superior roll rate to shake pursuit. Mahurin followed, the modified turbocharger keeping his engine producing maximum power through the violent maneuvers. At 24,000 feet, Mahurin fired a 3-second burst from his 850 caliber machine guns. The FW-190's left-wing root erupted in flames and aluminum fragments. The German fighter rolled inverted and dove into the cloud layer below, trailing black smoke. The engagement lasted 14 minutes. The 61st Fighter Squadron claimed 5 FW-190 seconds destroyed with 2 more listed as probables. Not a single P-47 took significant damage. More importantly, pilots came back reporting something they'd never experienced before: the ability to stay with FW-190 seconds during vertical maneuvering. The altitude advantage that had kept German fighters alive for months had just evaporated. Word spread through the 8th Air Force's fighter groups like tactical gospel. Pilots from other squadrons started asking 56th Fighter Group pilots what mechanical magic had transformed their Thunderbolts. By early April, crew chiefs from the 4th Fighter Group, the 56th Fighter Group's sister unit at Debden Airfield, were making unofficial visits to Halesworth to watch Kovich work. He taught them the modification technique, explained the spring compression measurements, shared his grinding jigs. The modifications spread from group to group, usually without official authorization, always with the implicit blessing of maintenance officers who'd decided that winning the air war was more important than following technical orders written in Farmingdale, New York. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Within 3 weeks of Wetmore's test flight, approximately 70 P-47 seconds across 3 fighter groups had been modified using Kovich's wastegate actuator technique. The statistical impact was undeniable. In February and March 1943, 8th Air Force P-47 squadrons averaged 1.4 enemy aircraft destroyed per Thunderbolt lost. In April and May 1943, after widespread adoption of the wastegate modification, that ratio jumped to 6.2 to 1. Some of that improvement came from pilot experience, better tactics, and improving coordination with bomber formations. But the climb performance advantage was the multiplier that made everything else work. Thunderbolts could now engage German fighters on more equal terms, using their superior diving speed and now competitive climb rate to attack when they had advantage and disengage when they didn't. The tactical transformation was profound. Before the modification, P-47 doctrine emphasized maintaining altitude advantage at all costs. If German fighters attacked from above, escort pilots were supposed to dive away and reform, accepting that they couldn't climb back to engage effectively. After the modification, Thunderbolts could fight vertically with confidence, climbing to meet German fighters who expected to control the high ground. Pilots described it as finally being able to use the Thunderbolt's power the way Republic's advertising brochures had promised. Major Hub Zemke wrote in a classified after-action summary, "This field modification has fundamentally changed the tactical effectiveness of the P-47 European combat operations. For the first time, we can fight German fighters in 3 dimensions instead of 2. The Army Air Forces discovered the unauthorized turbocharger modifications through an unexpected channel. A Republic aviation engineer visiting Halesworth on April 18th to investigate why P-47 combat performance reports no longer matched factory test data. Harold Peterson had spent 3 days at the airfield, interviewed pilots about climb rates, examined maintenance logs, and eventually noticed that nearly every aircraft in the 61st Squadron had identical tool marks on their turbocharger access panels. Tool marks in specific patterns meant panels had been removed repeatedly. Panels removed repeatedly meant someone was working on turbocharger systems frequently. Peterson asked to inspect one of the aircraft, and within 30 minutes had discovered the modified wastegate actuator spring. His initial reaction, documented in his field report, was horror. Someone had modified a critical engine management component without engineering approval, without structural analysis, and without any consideration for the catastrophic failures that could result from turbocharger overspeeding. Peterson's report landed on Colonel Hub Zemke's desk on April 20th, and Zemke's response was immediate and unambiguous. He confined it to his desk drawer and pretended he'd never received it. But Republic Aviation wasn't going to let this disappear quietly. On April 23rd, a formal investigation team arrived at Halesworth. 2 engineering officers, a legal specialist from 8th Air Force Headquarters, and a civilian turbocharger engineer from General Electric who'd been flown from Massachusetts specifically to assess the modifications and determine failure risk. Their preliminary conclusion took 4 hours to reach. Every modified turbocharger was operating outside manufacturer specifications. The reduced spring tension eliminated a critical safety margin, and continued operation created unacceptable risk of engine overboost and catastrophic failure. They recommended immediate grounding of all modified aircraft, replacement of every altered wastegate actuator, and a disciplinary action against Technical Sergeant Michael Kovich for willful destruction of government property. Kovich was formally notified of pending charges on April 25th. The specifications were serious: unauthorized modification of critical flight systems, violation of technical orders, and conduct prejudicial to good order and discipline. Maximum penalty if convicted: 3 years confinement at hard labor, dishonorable discharge, forfeiture of all pay and allowances. Then Colonel Zemke did something that violated several layers of military protocol. He sent a classified cable directly to General William Kepner, commander of 8 Fighter Command, that included combat statistics, pilot testimony, and a blunt assessment. If this court-martial proceeds, you'll be punishing the person responsible for turning the P-47 from a marginal escort fighter into an effective combat aircraft. You'll also be telling every crew chief in England that solving problems gets you imprisoned. The combat data was impossible to ignore. Fighter groups flying modified P-47 seconds were posting kill ratios averaging 6-1. Groups still flying factory specification aircraft were posting 2.3-1. Pilot after pilot testified that the improved climb performance had fundamentally changed their ability to engage enemy aircraft effectively. Lieutenant Mahurin, who'd scored 8 kills in 4 weeks flying a modified Thunderbolt, told the investigation board, "I'm alive because my aircraft could climb with the enemy. If you court-martial Sergeant Kovich for making my aircraft competitive, you're court-martialing him for saving my life and the lives of every other pilot in this squadron." The General Electric engineer complicated matters further. After examining 17 modified aircraft, conducting ground tests, and reviewing engine performance data, he concluded the modifications were functionally sound. The reduced spring tension wasn't causing turbocharger overspeeding because pilots were using war emergency power judiciously, exactly as Kovich had anticipated. Oil temperature data showed engines were running warm, but within acceptable limits. Most importantly, there had been 0 turbocharger failures in modified aircraft over 6 weeks of combat operations. The engineer's report included a critical observation. Republic Aviation's wastegate controller had been calibrated for maximum engine longevity, not maximum combat performance. Kovic's modification shifted that balance toward performance, accepting marginally higher engine stress in exchange for substantially improved combat capability. From a pure engineering standpoint, it was a defensible trade-off. From a procurement and liability standpoint, it was a nightmare. The court-martial never happened. On May 7, 1943, 8 Fighter Command issued a memorandum stating that no disciplinary action would be taken against Sergeant Kovic or any personnel involved in turbocharger modifications. The memo acknowledged that unauthorized modifications violated regulations, but concluded that the modifications in question substantially improved combat effectiveness, involved acceptable operational risk, and were undertaken in good faith to address performance deficiencies affecting mission success and pilot survival. It was as close to an official commendation as a potential court-martial could produce. Kovic was returned to full duty and quietly told to stop modifying turbochargers until the Army Air Forces decided on official policy. That decision came faster than anyone expected. On May 15, 1943, Republic Aviation issued Technical Order P-47142, officially authorizing modification of wastegate actuator return springs on all P-47 variants operating in combat theaters. The technical order specified the exact spring compression length Kovic had determined through trial and measurement, 2.5 inches under zero load, providing approximately 24 pounds of return force. Republic's engineering team had spent 3 weeks validating what Kovic had proven in one night with a grinding wheel and a spring compressor. The modified specification increased turbocharger response speed by 40%, reduced time to maximum boost from 45 seconds to 23 seconds, and improved climb rate at 15,000 feet by approximately 18%. Every number matched what pilots had been reporting since late March. More importantly, Republic's testing revealed something Kovic hadn't known but had somehow intuited. The factory spring specification had been overly conservative, designed with excessive safety margins to account for worst-case scenarios that rarely occurred in practice. The modified spring was actually closer to the optimal value for combat operations, where pilots needed maximum performance and were trained to monitor engine instruments carefully. By June 19, 1943, modification kits were being distributed to every P-47 unit in England. The kits included pre-measured replacement springs, installation instructions, and updated engine management guidelines. Aircraft still in production at Republic's Farmingdale and Evansville plants began rolling off assembly lines with the new specification installed. Within 3 months, approximately 1,500 P-47 seconds had been retrofitted with what Republic's documentation called combat-optimized wastegate actuators. The documentation specifically credited field observations and modifications implemented by USMC maintenance personnel for identifying the performance deficiency. Kovic's name appeared in 2 separate engineering reports, unusual recognition for an enlisted man in a system that typically credited officers for innovations, regardless of who actually invented them. The performance improvement cascaded through 1943 and into 1944. P-47 kill ratios in Europe climbed steadily, eventually reaching 11-1 by mid-1944. Some of that improvement came from pilot experience, German fuel shortages, and the introduction of long-range fuel tanks that let Thunderbolts escort bombers all the way to Berlin. But the climb performance advantage remained fundamental. P-47 seconds could now fight Focke-Wulf 190s and Messerschmitt 109Gs on equal vertical terms, could zoom climb to regain altitude after diving attacks, could maintain position advantage during extended engagements. The aircraft finally performed the way its designers had promised when they'd strapped a turbocharger to the most powerful radial engine in production. By war's end, the P-47 had destroyed more enemy aircraft than any other American fighter type in the European theater. The numbers are staggering. approximately 3,700 aerial victories, plus thousands more aircraft destroyed on the ground during strafing attacks. The Thunderbolt had become the workhorse of the 8th and 9th Air Forces, flying more sorties, dropping more bombs, and providing more effective escort than any other fighter in the theatre. Kovich finished the war as a master sergeant, training turbocharger mechanics at Republic's Modification Center in Evansville, Indiana. He never received a medal for the wastegate modification. The Army Air Forces didn't award decorations for violating technical orders, even when those violations turned the tide of air battles. But he received something more lasting. In 1948, the Society of Automotive Engineers published a technical paper on field modifications in combat zones. Kovich's wastegate actuator modification was cited as a case study in adaptive engineering, an example of how frontline maintenance personnel could identify and solve performance problems that escaped factory engineers working thousands of miles from combat reality. In 1952, when the Air Force established formal procedures for evaluating field-proposed modifications, the regulations specifically referenced the Kovich Protocol, a framework for crew chiefs and maintainers to propose, test, and validate modifications when combat experience revealed deficiencies in factory specifications. The protocol required engineering review and approval, but it legitimized the principle that the people closest to combat operations often saw problems that distant engineers missed. The modified turbocharger control strategy influenced post-war fighter design. When Republic designed the F-84 Thunderjet, their first jet fighter, the engine control system was engineered for rapid throttle response rather than maximum component longevity. When North American Aviation designed the F-86 Sabre, they consulted with 8th Air Force maintenance personnel during the development phase, asking what field modifications had been necessary on previous fighters and why. The principle Kovich demonstrated in March 1943 became doctrine. Combat effectiveness sometimes requires accepting higher mechanical stress, trusting operators to use systems responsibly, and optimizing for mission success rather than maximum equipment lifespan. That philosophy shaped every American fighter designed during the Cold War. Michael Kovich returned to civilian life in 1946, worked as an aircraft mechanic for TWA for 28 years, and died in 1982 without ever knowing that his turbocharger modification had fundamentally influenced how military aircraft were engineered. Because it did influence everything, not immediately and not obviously, but the principle he stumbled onto became foundational. In modern fighter aircraft, engine control systems are designed for aggressive response characteristics. The F-15 Eagle's engine can go from idle to full afterburner in 4 seconds. The F-22 Raptor's thrust vectoring system can redirect 25,000 pounds of thrust in less than 1 second. These capabilities exist because engineers learned, slowly and painfully through cases like Kovich's, that combat demands performance margins that peacetime engineering would consider reckless. The real legacy shows up in how the Air Force approaches field modifications today. There's a formal system now, the Air Force Technical Order System, that lets maintainers propose modifications based on operational experience. Those proposals get engineering review, testing, and validation, but they get considered seriously, treated as valuable input rather than violations of factory authority. Kovich didn't create that system, but his wastegate modification helped prove it was necessary. Modern aerospace engineering has a principle called operational requirements validation. It says that a system's design requirements should be validated against actual operational use, not just theoretical performance specifications. The textbook example, taught at the Air Force, Institute of Technology, and every aerospace engineering program that studies military aircraft, is P-47 turbocharger response optimization. How a factory specification optimized for engine longevity proved inferior to a field modification optimized for combat effectiveness. How reducing safety margins actually improved safety by giving pilots the performance they needed to survive. Most students never learn about Kovich. They learn about Republic Aviation's responsive modification program, as if it was a corporate initiative rather than a desperate attempt to legitimize what an enlisted mechanic had already proven with a grinding wheel and borrowed spring compressor. That's fine. The specific attribution matters less than the principle. What matters is understanding that the person maintaining equipment in combat conditions might understand that equipment's requirements better than the engineer who designed it in peacetime. What matters is recognizing that safety margins calculated in factories might be wrong for the actual operational environment. What matters is having systems that let Michael Kovic's propose modifications without risking court-martial, because the next war will produce its own performance problems that factory engineers won't anticipate. Kovic shortened a spring by 1/2 inch in March 1943. By doing so, he shortened the time it took P-47 seconds to reach combat altitude by 20 seconds, and shortened the war by however many missions those 20 seconds saved, however many pilots came home because their aircraft could finally climb like the Germans couldn't ignore anymore. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.